Okay. Now we are going to study graphs. Okay. But I show you here. What's happening is we are going to study displacement time graph. Okay. So sometimes they are called position time graph. Okay. Now here is an example of a displacement time graph. Okay. So on the vertical axis here, okay, we have displacement in meters or in centimeters. Okay. And in the horizontal axis, we have time. Normally, they will be in seconds. So most of people, when they first looked at displacement graph, okay, the way they analyze it would be, okay, we have something traveling at here and goes downhill and goes uphill. So, but this is wrong. Okay. Now I show you what they really means. Now here is a simulation. Okay. Now I have a man standing in the middle, 0 meters. Okay. And if you look at the first graph here, we have position time graph. The first graph is displacement time graph. Okay. So don't worry about the rest too. We do them later. For now, just look at the first graph as I move the man around. Okay. Say if I move the man, okay, from 0 meters to 4 meters and stop. Okay. What does the graph tells me is initially as time goes, we have a flat line there. It means the man doesn't move, and suddenly he moved to 2 meters. Sorry, 4 meters. Then it the man stands still for a period of time. So the displacement of the man to the original point doesn't change. Okay, means he stays stationary, he stays still. Okay. Then if I drag the man, say the man moved um, to 10 meters there. Yep. We have another upwards thing on the graph. The graph tells me during this time of period, the man traveled from displacement of 4 meters to 10 meters. Okay. He traveled 6 meters. Okay. 10 minus 4 is 6. He traveled from here to here. Okay. Then the graph is flat, means he's standing still for a period of time. Okay. Then I move the man back to the original. I have this nice looking line there, means he traveled backwards from a displacement of 10 meters to 0 meters. Okay. Then he stands still. So if I move it to the negative direction, so this tells me the man actually traveled, reading from the graph, 4 meters below. Okay. Now, if I move it back, it looks like this. So this is position time graph. It's only dealing with one-dimensional movement. Just remember, it looks like uphill and downhill, but actually it's just moving forward, forward, backward, backward, forward. Okay, so let's do an example on here. Okay. Have a look at this graph. Okay. So if we have a look at this graph at the initial position when time is 0, okay, so an object, so the object is here. Okay. Say this is the original point. Okay. The object is 4 meters. The object is 4 meters further to the original point, okay, because the displacement 4. He stands a while. He stands still for 10 seconds. Here is the time. Okay. Yep. Okay, we have time in seconds here. He stands still for 10 seconds. Okay. Then he traveled backwards to the original points in the next 10 seconds. Okay, because 10, 20 take away just, yeah, just 10 seconds. The time between that would be 20 take away 10, which is another 10 seconds. So he traveled back. Afterwards, he traveled forward to 3 seconds, as you can see. Well, let me just label it. 10 seconds later, he traveled forward to 3 meters. So he traveled forward to 3 meters. Okay, let's say 3 meters is approximately here. Okay. Then he starts to travel backwards with a displacement of -3. Okay. So sorry, imagine we have our number line there. We have 0. I have 4 meters. Then he travels in the next 10 seconds, travels back to say -3 meters. Okay. There stands still for a few seconds, 5 seconds, I think. Just approximately 5 seconds. Then the man travels back to the original points. Okay, in 10 seconds time. So this is how do we read our displacement time graph. It tells us how does an object moves forward and backwards. Okay, so if you are really interested about this, I can I can show you where to go to this simulation. Basically, just move the man backward, forward, backward, forward, backward, then stop it. Then you have a position time graph. It traces how did you move. So the idea, if you want to go to this simulation, now what can I tell you to do is go to Google. Just type in FET physics, FHET, FET simulation. Press enter. It's going to be the first few links. I just click on it. The idea is let's go to the home page. Go to the home page, then click on play with simulations. Go to physics. Go to motion here. You can find that simulation in the list is called the moving man here. Just click on it and click on run now. Then you have basically you have this coming up. You need to So you're welcome to play around with it.